Okay, hi everyone. I'm sorry I'm not there with you today, but let's go through section 5. Right, before we begin, a tiny quiz. What is a logarithm? An exponent. Good, awesome. Okay, so let's do this. So, what is the exponent of 2's that would get you an 8? Right, it's 3. What is the exponent of 2's that would give you, I don't know, a 4? Right, it's 2. Okay, so now, what is the exponent of 2, right, that would give you 32? That's the multiplication of 8 times 4. So what exponent of 2 would give you 32? Correct, that's 5. Okay, so what happened? When I multiplied 8 times 4, in order to get the exponent of the resulting product, I had to add the exponents of the individual parts, right? Now, if this is a logarithm, right? And if I said, what is log base 2 of 8? You would say 3. What is log base 2 of 4? You would say 2. What is log base 2 of the product? You would add the exponents, okay? So when I multiplied the two numbers, I ended up adding the exponents. This is very, very important because this concept introduces us to the three properties of logarithms, which are the product, the quotient, and the power properties. We're going to start with the product property, which is exactly what we just did. The product property says this: log base b of a product is equal to log m plus log n, right? And if a logarithm is an exponent, then the exponent of the product is the sum of the exponent of the individual parts. Okay, so we have to remember this. Here is the same sort of logic right here. Log base 2 of 8 times 4. Well, this is 2 cubed and 2 squared, right? This is equal to log base 2 of 8 plus log base 2 of 4, okay? Well, here, the total exponent over here is a 5, whereas here you have an exponent of 3 plus an exponent of 2, and that's how they are equal to each other. All right, so when you have log base 2 of m times n, we add the logarithms of the individual elements. So take a look here. We are given that log base 3 of 2 is this. Somebody did it on their calculator and they told us. Log base 3 of 7 is this. We have to use that information to evaluate log base 3 of 14. The first thing you have to do is you have to write the 14 as a product of two numbers, preferably these two. Well, we know that 14 is just 2 times 7. So now if you have log of m times n, you have to separate them, right? So this becomes log base 3 of 2 plus log base 3 of 7. Basically, you have to give each element in here its own log, and we're going to add them. And then we were told that log base 3 of 2 is 0.6310 plus log base 3 of 7, 1.7712, and together that will be 2.4022. So presumably, right, you wouldn't really need a log function on a calculator to do this if you were given those two values at the beginning. Okay, what about the quotient property? Well, we know that, so when you have log base b of m divided by n, we know that when we divide powers, we subtract the exponents, right? So that means log base b of m over n is log of m minus log of n. Okay, so here I have log base 2 of 3, log base 2 of 7. I need to find log base 2 of 7 over 3. So if there is a division here, I have to subtract. So give each person its own log, and then minus log base 2 of 3, right? If I'm dividing, then I subtract. Now plugging it in, log of 7 is 2.807 minus 1.585, together 1.222. Okay. Next, we have the power property, which says if you have log base b of m to the power of p, that p moves down here and becomes a coefficient of the logarithm. So again, same situation, log base 2 of 3, log base 2 of 7. Now we have to do log base 2 of 36. With a more complicated number like that has several factors, it's nice to do a factor tree. Okay, so I'm just rewriting. I'm not really doing a lot of math here. So this is going to be log base 2. And then 36, you see, is 3 squared times 2 squared. I literally didn't do any math. I just broke up the 36 into its factors. So now I have a log of a product. I'm going to separate that. So I'm going to have log base 2 of 3 squared plus, multiplication means plus, log base 2 of 2 squared. Now, this moves down, this moves down. 2 log base 2 of 3 plus 2 log base 2 of 2. Okay. All right. This is 2 times. I know what log base 2 of 3 is. I'm given that here. 1.585 plus 2 times. Okay, what about this? What's log base 2 of 2? Wait, what is the exponent of 2 that would give you a 2? Oh, that's just a 1. Okay, I didn't even need to be given that one because I already know. Simplifying this gives me 5.17. Okay, next, log base 2 of 0.75. I don't know. How can we write 0.75 in terms of a 3 and or a 7? Well, the only thing I can think of is 0.75 is 3 over 4. Okay, I can work with that. So this will be log base 2 of 3 minus log base 2 of 4. Okay, I'm given log base 2 of 3 minus, and I know what this is, that's a 2. Isn't that lovely? So I get negative 0.415. Okay, fabulous. All right, so let's solve each of these equations. To solve this, I need to use the properties that I was using last lesson, which is if you have identical logs, you can set their insides equal to each other. This one we're almost there, except this 1 over 3 needs to go back and become an exponent, right? So that's basically what we were doing here, but it could go in either direction. Okay, so this p can go back and forth between a fraction, a coefficient, and an exponent. So now I have log base 5 of m to the power of log base 5, 125 to the 1/3. Okay, this is log base 5 of m equal to log base 5, 125 to the power of 1/3, cube root of 125, 5. Okay. So what now? I mean, we're pretty much done, right? Because I have log base 5, log base 5. All I need to do is I need to set m equal to 5, and we're done. Okay? All right. Here, I have a different problem. The problem is I have too many logs on each side. So what I have to do is called condensing. I need to condense first so that I only have one logarithm in each side. The way in which to do that, first step is go through and make all of the coefficients into exponents. So this is log base 3y squared, log base 3.1 equals, basically I'm just copying over. Okay, now, on this side, I need to condense this. So remember, if you're adding two logarithms, you can combine them and you can multiply the stuff inside. So this will condense into one logarithm. And here I have y squared times 0.1. Equal to log base 3, multiply these, 5 times 2. So here I get 0.1 y squared equal to 10. Now I need to divide by 0.1, divide by 0.1. So y is equal to, y squared is equal to 100. Now what do? Take a square root, take a square root. So y is plus or minus 10. Here, I have one logarithm here, that's fine, but I have way too many on this side. So each of these are going to become coefficients, exponents. So log 7m is equal to log base 7, 64 to the 1/3, plus log base 7, 121 to the half. So here, I have log base 7 of m equal to log base 7. If these are being added, then I can multiply the stuff inside. So 64 to the 1/3 times 121 to the 1/2. Okay, now take a look. I have log base 7, log base 7. I can set the insides equal to each other. So m is 64 to the 1/3. Cube root of 64, that's basically 4 times the square root of 121. So this is 44. All right, here. I believe there is a parenthesis missing here. Why is it doing this? Okay, so here we go. Okay, we're going to condense this. So it's going to be log base 6 x times x plus 5 equal to 2. Okay, now this is a different situation altogether because you only have one logarithm on one side only, nothing on the other side. Well, it means here we have to use our exponential properties. So remember, the answer to a logarithm is an exponent. Every exponent needs a base. So that means 6 to the power of 2 is equal to x plus 5. And wouldn't you know it, this transforms again to a lovely quadratic equation. X squared plus 5x minus 36 is equal to 0. X plus 9, x minus 4 is equal to 0. X equals 9, negative 9, and x equals 4. Okay, and when you check, actually, x equals negative 9 does not work because you can see here you can't plug it in. So just x equals 4. Okay, here we go. Ooh, what about this one? So let's condense first. So this is log base 2 x to the power of 4 minus log base 2 of 5 equals log base 2 of 125. Okay, this time we have a division here, that means subtraction here. That means we have to divide. The first one, okay, so log base 2, right? The first term is going to be the numerator. Also because the sign for this one is positive, so it'll be in the numerator. But the sign for this one is negative, so it'll be in the denominator. equal to log base 2, 125. So I have x to the power of 4 over 5 is 125. And let's simplify. X to the power of 4 is 625. Fourth root. So x is equal to 5. Okay, next one. So here, this 2 becomes an exponent, equals log base 7 of 27 times 81. Now, this could very easily be a non-calculator question. So hold off multiplying first, because at this step, I can set these equal to each other. And now all I'm going to do is take a square root. So x is what? The square root of 27, which is 3 root 3, times the square root of 81, which is 9. So x is 27 root 3. Except, what have I forgotten here? Yep, plus or minus. All right, so 27 root 3. Now, okay. Oops, sorry. However, the negative of this is not going to work here. So x is just 27 root 3. Okay, let's move on. Another very important place that logarithms are used, besides the Richter scale, is pH. pH is the measure of how acidic a substance is. For example, something like a lemon, which is acidic, might have a pH of 3, and so on. Okay, so how do you find the pH? It's basically a formula, negative log base 10 of H plus in brackets. This means the concentration of H plus ions. Okay, so it's a concentration, hydrogen ion concentration. Okay, so what is the pH of a solution whose hydrogen ion concentration is this many moles per liter? So we want the pH. So we say, okay, pH is negative log base 10, 6.3 times 10 to the negative 3. Okay. So what is this? This is negative, let's do some math here. Log base 10, 6.3, plus log base 10, 10 to the negative 3. Okay, now take a look. This negative 3 will come down. So I have pH equal to negative log base 10 of 6.3. Okay, minus 3 times, right? Because the negative 3 comes down. And then what do you have left when the negative 3 comes down? Log base 10 of 10. So what's the exponent of 10 that gives you a 10? 1. So that's, just 1. Okay, now, how do we plug that into our calculator? Well, let's see. Let's go here. So if you look, so press the control button and go 1, 2, 3 buttons down. Right to left of 1 is the logarithm, and you can put in a base of 10, 6.3. All right, and that's 0.799. Okay, so when you plug all that in, okay, so let's do all that in one shot. So we're going to do negative, go up, oops, sorry, negative in parentheses, this minus 3. So you get 2.2. Okay, so the pH is 2.2, and that's pretty acidic, actually. Okay, what is the hydrogen ion concentration, this, of a solution whose pH is 8.5? Well, let's see. pH is negative log base 10 of the H plus concentration, hydrogen ion concentration. So 8.5 equals negative log base 10 of the concentration. Okay, so we divide both sides by -1, so I get negative 8.5 equal to log base 10 of the hydrogen ion concentration. Okay, what happened again? We have a logarithm on one side, but it's okay because what is the answer to a logarithm? That's right, it's an exponent. So this is the exponent. Every exponent needs a base. 10 is the base. So I have 10 to the power of negative 8.5 is equal to the H plus ion concentration. And you can actually leave it like this because plugging this in is going to give you a very, very tiny number. Okay? All right. So there we go. There was properties of logarithms. You can go ahead and start on your homework. It'll be due next class. Have a good day, everyone.